Hello, welcome to Functions 1.2, Function Representation. Okay, in today's lesson, you'll learn about the different ways that we can represent functions. Yeah, and you can represent it visually using a graph, numerically, which is using a table, symbolic representation, which kind of looks like a formula, the kind of formulas that you guys have been using in probably science classes and other math classes. Yeah. And there's also a word representation, which isn't in this list on this first slide, but you will see an example of it when we do some of the problems on this video. Okay, so look out for those four. All right, so let's see, what do we have today? So we have this scenario where it says, let's create a function to represent the cost of purchasing songs on iTunes that sell for $1.29 per song. Which of the following, are accurate representations of this function? And x represents the number of songs purchased, p of x. Yeah, so when I say p of x, it looks like it's just p parentheses x, but when you read it as a function, which is function notation, you're going to say p of x. Okay, so p of x represents the cost for purchasing x songs, and for each representation that fails, so it doesn't really map out the scenario that we're explaining here, where you're buying songs for $1.29 per song, you got to pretty much say why it fails. Yeah, so when I hit the answers, it kind of tells you which ones are going to be yeses and nos right off the bat, because if it's a tiny little box like the one in letter A, then you probably know it's going to be a yes or a no. Yeah, especially when it says if it fails, meaning it's a no answer, you got to explain why it fails. So if it's going to be one tiny box, I'm not going to make the explanation in that small, tiny little box, right, and just put it as like 1-point font. So yeah, when you kind of see the boxes that are representing each problem's answers, then you kind of know which are going to fail, because the yes answers are going to be tiny little boxes, the no answers are going to be a little bit bigger. Yeah, so yeah, we can kind of already tell that letter A. Yeah, so it says P of x equals $1.29, or 1.29 times x. Right, and isn't that how you figure out how much you're going to pay based on X amount of songs you buy? Right, you multiply how much you buy by the price, and you're going to get the total, the amount you're supposed to pay in total. Yeah. So letter A, that's going to be a yes. This maps it out perfectly. Yeah. And this would be called symbolic. Okay, so this first one would be called symbolic representation, because it looks like a formula. Okay, let's look at letter B. Okay, so you know this is a no already right off the bat, because the box is so big. So why is it no? Yeah, so let's see, what does this do? It's just the P of x, which is how much you're going to pay, is equal to the number of songs plus $1.29. So if I buy 5 songs, then I add $1.29, and that's how much I pay. Does that sound right? That'd be actually pretty cool, right? If I buy 5 songs and I just gotta add 5 to $1.29 and I get my total, nah, that's not how it's gonna work, right? You're not gonna add $1.29 to how much songs you buy. You're supposed to multiply. So that's pretty much why it's wrong. So the reason it fails is because, you're adding $1.29 to the number of songs you buy. You're not supposed to add, you're supposed to multiply, like in letter A. Okay, let's look at B. Okay, so this would be a word representation of a function. Okay, where you're pretty much describing in words what you're going to do to get your total, your P of x value, like how much you're supposed to pay for the amount of songs that you buy. So x is a number of iTunes songs that we can buy with P of x dollars at $1.29 per song. Yeah, so this is good. This is a yes. Yeah, this maps out pretty much perfectly what I want to do, right? I want to get a total based on how many songs I buy, and we're gonna price it out at $1.29 per song. Yeah, so this is what I want. So this is an example of word representation. Okay, all right. So let's look at our next problem, letter D. Okay, so D and E are what we call table representation. Yeah, because it pretty much just lists out visually, or lists out all the different scenarios that we have. So let's look at this first one, letter D. Because if I buy 0 songs, I pay $0. I would hope so, right? I don't want to be paying for songs that I don't buy, right? Okay. If I buy 1 song, I pay $1.29. If I buy 2 songs, I pay $2.58. 3 songs, I pay $3.87, and 4 songs, I pay $5.16. Okay, so basically to see if this works, you just gotta multiply 1, 2, 3, 4 by $1.29, and if the values on the right side are correct, when I multiply each one by $1.29, then they're good to go. The humbug thing about a table is all all it takes to say no for a problem is one occurrence to be wrong. Yeah. So you could have every single value correct in your table, but if one of them is wrong, then the entire table fails. Okay, so that's the humbug part. You got to check every single one. Yeah. So if you find one that fails early, then good, you're good to go. You don't have to check anymore because you're done. You found one that fails, so the whole table is pretty much game over. Yeah. But if the one that doesn't work is the very last one on the table that you check, then yeah, it made pretty much all that work that you did kind of seem for nothing because you checked every single one passed until the very last one, and then it fails. It didn't work. Yeah, so that's going to be the frustrating part. So you got to check every single occurrence in that table to see if every single one works. So when we multiply $1.29 times 0, 1, 2, 3, 4, yep, those are all the corresponding P of X values that you're supposed to get, so it's good to go. And yes is the answer for this problem. Okay, so in letter E, what do we have here? So we buy 5 songs, we pay $6.25. We buy 10 songs, we pay $12.50. Ooh, if I'm paying $1.29 per song and I buy 10 songs, right? 10 times $1.29 is not $12.50. 10 times $1.29 is supposed to be $12.90. So do I have to check any more values? Well, I didn't really even check the first one because if I did check the first one, I would have realized that 5 times $1.25 makes $6.25. But I didn't really want to do that math in my head, so I went to the next easier number, which was 10. So yeah, good thing I went and looked at the easy number first, which is multiplying by 10, because all you got to do is move decimals. So when I check x value 10, $12.50 is not the value I'm supposed to get. So right away, I don't have to check anymore. This thing fails. So this would be a definite no. Okay, and let's see. No, this table represents when the cost is $1.25 per song. Yeah, so when you check it, divide the P of X column by the X column, and you'll get $1.25 for each answer. So you don't got to check all of them. Yeah, like I said, once you find one value that doesn't work, that doesn't match the data that we have, which is $1.29 per song, you can stop right there. You don't have to check anything else. Yeah, once you find one occurrence that doesn't match your numbers, then game over. You just say no. Okay, so these are both table representations. Okay, next one, F. Okay, these two are graph representations because obviously these are graphs. Yeah, so the previous slide, those are tables. Next slide, which is now, these are graphs. So kind of like duh, right? we pretty much give the name to the representation based on what it looks like, yeah, for some of these things. Okay, so what do we have? We have one song corresponding to a number that we can't really figure out because it's kind of in between 1 and 2. So let's not use that one. Yeah, or maybe we can. Yeah, is that dot at a height of $1.29? Is the second dot 2 comma 2.58, and the third one is at 3 comma, what would be 387? Yeah, does that look like it kind of matches? Could it be believable that it's corresponding to those numbers? Yeah, I guess so. It's close enough. I mean, we don't know exactly what height that dot is exactly because we don't know exactly what the height is because it's not really at a nice number. So it's gonna be, yeah, we're gonna hope that it is, and it's gonna be a yes. Okay, actually, we're not gonna hope. We're gonna pretty much say, yeah, it's good to go. It looks good to go. Okay. But in G, let's see. We see a big box. We know it's going to be a no. So what's a dot that we can pretty much have concrete evidence that this is not working? So let's look at 10. Yeah, because 10 songs matches up with $20. So am I supposed to pay $20 for 10 songs? If I did, that means I'm paying $2 per song. Is the scenario that we have saying we're going to pay $2 a song? No, the scenario we have says we're going to pay $1.29. So this would definitely be a no. Yeah, and this graph represents when the cost is $2 per song. So make sure when you say no, yeah, when it fails to represent the scenario, make sure you kind of tell me what's going on. Yeah, like why does it fail? What's wrong with these numbers? What is it doing instead of doing $1.29 or whatever it's supposed to do? Yeah, so give me some kind of evidence that you know why it's a no. Yeah, for yes, you don't really have to give the evidence. It'd be nice if you did, but yeah, kind of like when you look at the data, when you look at the graph, you look at the table, you look at the description, then you can kind of figure out that, yeah, it's a yes. Yeah, so just give me the proof if you have a no answer. Okay. Okay. So your homework is going to be to do the reflections. So it's going to say, yeah, just going to ask you some random things to think about, and I kind of steer you in the right direction as far as what you're supposed to talk about or choose from, I guess you can say, in letters A and B. Yeah, so A and B, it says choose from, word, graph, table, or symbolic representation and explain. Yeah, so that's what you're gonna choose from in letters A and B for your reflection. And just write what you think. Yeah, and it's basically your opinion. Yeah, because everybody thinks different things are easy. Like some kids, right? They think math is easy. Some think math is super difficult, right? It's just based on what goes on in your brain. Yeah, so not everybody may like word representation. They may like symbolic. Some people might not like symbolic. They might like graph. Yeah, so just tell me what's going on in your brain. Yeah, so that's for A and B. And in letter C, yeah, just explain some advantages of the four different representations. Yeah, and some might not have advantages because you don't like them. You don't see anything easy about them. Yeah, or anything that they might have that's good about them. And that's just your opinion. Yeah, and some may have pretty strong opinions about why a representation is good. So just explain what are some advantages of the four representations, and yeah, that's it. Yeah. So there's pretty much like no right or wrong answer. Just tell me what's going on in your brain. What do you understand? What do you think? And that's your homework for section 1.2. Okay, so I'll see you in class. Bye bye.